Okay, whereby there are 8 blue balls and then 4 yellow blue balls. Sorry, 4 yellow balls. What am I talking about? Okay, 4 yellow balls. Alright, so in order for this to happen, okay, the probability the event that allows that to happen, right, is when if I were to take a box A yellow ball, put into box B, then from box B I take a blue ball out. You understand? So therefore the probability will be for this event to happen. So that means 5 over 12 times 3 over 11. So that will be 5 over 44. Are there any questions? Hannah? Yesterday which question is it that's not? Practice now 10, question 1. But 1 part 3. Okay. I thought I stopped at the 3 diagram. Yeah, I think you only yourself. I remember I only stopped at 3 diagram. Yeah, with the fractions. Yeah. Alright, are there any questions for this? Before I go back to yesterday's question. Sorry.
Huh? Okay, what's the good one? Then we asked you whether we have to simplify the fraction. And then he was like, then we ordered it out.
Yeah, I remember that, but I thought I just drew the 3 diagram.
So we continue on.
The last part you told us how to do.
You say like okay, then we just
Okay. So I stop part 3, yeah? Sure.
wait. Sorry. Watch the series.
So if I have to like
Question 1, right? Okay. You sure question 1 or not question 2, man? I thought I finished all the questions. Okay, now why?
4 or 7, 3 or 7 the one 64 is only.
Yeah, erase this part. Okay. Okay, so yesterday we were looking at the science demonstration, that one, right? Okay, whereby we are choosing 2 students, boys and girls. Okay, 16 boys and 12 girls. Then after that we drew this 3 diagram. Okay, then after that we stopped at part 3, where we want to find the probability that at least 1 is a goal. Right? So what's the probability of having at least 1 is a goal? What's the situations that we're looking at?
At least one's a girl. I thought we were doing different.
So that means it is either a it's either boy-girl combination, girl-boy or girl-girl combination, right? Okay. So in order to do this, right, at least 1, okay, we can consider the reverse, okay, the opposite, which will be 1 minus away probability of boy-boy. Correct? Okay, so in this case, that will be, the boy-boy combination will actually be 16 over 28 times 15 over 27. Okay, then we will get the answer to be 43 over 63. Okay. If you don't consider the reverse, you could also consider all the different combinations, which is boy-girl, girl-boy, and girl-girl. Okay, and then we will also still get the same answer, 43 over 63.
Next I put P, then bracket put P plus G plus.
No, cannot. Okay, presentation wise, this is the only acceptable one if you want to write it in short like that. Okay, it is not acceptable if you write BG plus GB plus GG. Okay, this is not a correct notation, right? So please don't do this. Okay.
Can you put
Here, huh?
Yeah.
Yes, can. You can replace with the word all. So you can replace this with all. You can do as one. Did I ask you to do question 2? No, right? Okay. Yes. Okay, I will skip question 2. I wouldn't want to go through that because it's rather repetitive. Okay, let's look at exercise 2C, question 19. Okay, so let's look at question 19A, part 1, 2, and 3. Right, so we are looking at a situation whereby we are throwing a fair die. Okay, we throw until the fair die is thrown repeatedly until 6 is obtained. So once 6 is obtained, that means the game ends already. Okay, so in A part 1, I'll just write in short. Okay, so A part 1, we want to find the probability that the game ends on the third row. Okay, so that means, right, on first row you are not getting a 6, second row not a 6, okay, third row it is a 6. You understand? Okay, so games end on third row. The game ends when you get a 6. Alright? So the probability, okay, I'll leave you to write the presentation, okay? So the probability would actually be first one not a 6, right? So what's the probability of not getting a 6? 5 over 6, right? And then after second row also not a 6, so that will be times 5 over 6. And then the third row it is a 6, and the probability will be 1 over 6. Okay? So it's not in all situations whereby you need to draw a tree diagram. Okay, in this case, if you were to go and pursue a tree diagram, okay, I think it will be very large and tedious. Okay, so you need to still know how to do your understanding your situation and breaking it down. Okay. So in this case, the answer will be 25 over 216. Okay, and then after that in part 2, okay, part 2 and 3 there is a difference. Part 2 is referring to ending on the 4th row, and then part 3 it is by the 4th row. So let's look at on the 4th row first. Okay, so on the 4th row, alright, that means it is similar to how we calculated in A part 1, right? So what would my calculations involve? Noel? What would my calculations involve for part 2? Okay, good. So 5 over 6 times 5 over 6 times 5 over 6 times 1 over 6. So we will get 125 over 1296. Okay. Then how do we actually do part 3? Probability that it does not end by the 4th row. Any suggestions? 1 minus? Okay, so is saying we take 1 minus 5 over 6 times 5 over 6 times 5 over 6 times 5 over 6. Why do we do this? Yes, it is faster, but why? What's the thought process behind it? What's this event that we're talking about? Okay. Okay, so actually the event that we're referring to over here, okay, will be we're taking 1 minus probability that it does not end by 4th row. So that means on the 4th row it still goes on. Okay. So for at the 4th row itself, okay, if it still goes on, that means it will be a 5 over 6. That means you're not getting a 6, right? So you're getting any number other than 6. So that's why the probability will be 5 over 6. Okay, any questions? Alright, so then we proceed in this calculation. We would get 671 over 1296. Okay. Now let's look at part B, whereby we change the situation. Okay, we change the situation to be such that it only ends, okay, when 2 6 are obtained. Okay, it is rolled repeatedly until 2 6 are obtained. So the ending point when there is 2 consecutive 6 are. Okay, because there's only one die. Right? So that means that if I want the game to end on the 3rd row, okay, how would I actually go about this calculation?
6 times 1 is 6.
Wait, ah. Yes, Teresa, what's your answer?
5 or 6 times 1 over 6 times 1 over 6.
So the game ends here. Rolled repeatedly until 2 6 are obtained. Ends on the 3rd row. Oh, okay. Wait, oh, sorry, my question, my understanding is wrong. Okay, the question is saying 2 6 are obtained. It doesn't mean that it must be consecutive. Question never say it's consecutive, right? Okay, so it does not need to be consecutive. Okay, so for it to end on the 3rd row, okay, it could be a case whereby my first row is not a 6, second row it is a 6, okay, 3rd row is a 6. Then I will get 2 6. Okay, so not 6, is 6, is 6. Okay, so I get 2 6 already, then the game ends by the 3rd row. Okay, is there any other combination that we can look at?
1 6 times 5 6.
It will also be a case whereby 1 6 times 5 over 6 times 1 over 6, right? Okay, whereby this is a 6, not 6, qubits.
Isn't the answer also, isn't the result also the same?
Okay, so now what Chloe is saying, we take 5 over 6 times 1 over 6 times 1 over 6 cube. But we need only square one. We don't, if we times 2 one, we don't square.
3 times?
We don't do 3 times also, you know.
Because the last one first.
Okay, because the other combination will be is 6, not 6, but the game already end at second row already. What? There is only 2 cases.
Why times 2?
You can times 2. Okay? But I rather you just think about all the possibilities than to do your immediate times 2. Okay, so that you don't miss out on any of the cases. Okay? So the combination of is 6, not 6 cannot happen because this will mean that at the third row, at the second row, right, the game would have ended. So there is no third row for you to discuss already. Okay? So in this calculation, we will get 5 over 108. Then after that, part 2 is even more complicated. We want a case whereby the probability ends on the third row and the sum of the scores are actually odd. So now we need to go and consider all the different sums. Okay? Okay, let's look at all the possible combination. Okay? So for it to end on the third row, it is either this or this combination, right? Okay, not 6 is 6 is 6 or is